Hello, welcome everybody. This is the April edition of Tech After Hours presented by the Assistive Technology Department at the California School for the Blind. My name is Shannon Stice. I'm one of the AT specialists there, and I'm joined by Max Avendano and Allison Mello, who are the other assistive technology teachers. This is a series that we have once a month. It's usually or so far always on a Tuesday night. The videos are also available on YouTube, so if you want to look at past videos, they're there on the channel for you to check out. I also want to just let it remind everyone that we are available to assist you with your assistive technology needs and questions. So you can contact us at CSB if you have questions or need help with a certain piece of technology. We can also come to you. We're able to travel and come to your school or school district and work with you. So please reach out if there's anything that you need. Tonight we're going to start, we're going to talk about um, math and technology and accessibility. I'm going to start by talking about the access gap. So the gap between students who are blind and visually impaired and mainstream students who have typical vision. So some of this, if you're a TBI or if you've been a student with a visual impairment, you've probably run into this before. Some of the challenges that students face with math concepts. So if you're using a screen reader or a refreshable braille display, those are typically only one line of braille, and a lot of math is spatial. So you think about even like elementary school math when you're doing spatial addition or spatial multiplication, where you have numbers on top of each other and the answer at the bottom. And then, of course, when you get into more advanced math, you have equations that are multiple lines. Plus, you also have there are graphics for example, in geometry and in early elementary or math, there's learning shapes. So there's the issue of graphics. And Braille displays and Braille note takers and screen readers only read one line at a time. So students aren't able
Step
to.
five, day five over again. When it said 53% sentence.
Oh, got someone. So students are only able to access one line at a time and not really the spatial nature of the math. Um, which means that students are often required to memorize parts of equations or constantly going between lines. So there's a lot of just navigating back and forth, or they have to go back to parts of an equation. So it just adds a lot of extra effort and work for our students. Uh, One question. Oh, also, sorry, I was left out the part about the part to whole examination. So just having uh, blah, sorry, it's just making having the single line of Braille on the display, it just makes it all more complicated. And the question that we had was, can AI help? So AI is everywhere now, and it's becoming a increasingly big part of assistive technology. Um, the answer is AI can sort of help. It can't change linear math into spatial math or vice versa. So we're not able to do that with AI. There are a lot of and a growing number of AI tools uh, that can make math assignments more accessible, turn them into accessible formats that can be read by screen readers and braille displays, that they can describe images like graphs and things like that. So there is that aspect of AI that's helpful, but it's not 100%. It can't just fix everything at this point. Um, let's see. There are for example, there's something called Equagio, which is a Chrome extension. which really simplifies the process if you're trying to create accessible math problems and equations. It doesn't, you aren't required to know any special code or anything to create the math. So it makes it much simpler that way. Equalizer is another one. It's a free application that does something similar. It just kind of simplifies the whole process of creating accessible math and doesn't require that you know any special code or anything. JAWS now has Picture Smart capabilities, which is AI based. So it can help to identify and describe images, which is could be really useful in math, obviously. Another aspect of this is spatial concepts. So we think about geometry and graphs, tactile aspects of math. And there are several low tech and maybe kind of medium tech tools that students can use to interact with spatial concepts like geometry and graphs. So one is the math window. If you haven't seen the math window, it's like a magnetic board with a frame around it, and you use tiles that have numbers in print and braille, math signs, and other signs that you need to um, create equations and to solve equations. And it's really useful for students to learn spatial concepts of math, how to arrange problems, how to solve problems once they're arranged spatially. And you can also use it for other spatial concepts for graphing and things like that. The Draftsman from APH, which is available on Quota, is just, it uses uh, kind of a plasticky film paper and a stylus, and it goes over a rubberized board, and you're able just to draw on it and create tactile images immediately. You don't have to print them or anything. They're just there once you start drawing. So that's great for kind of on the fly or maybe in a classroom setting or just if you need to do things quickly, you can prepare images and things pretty fast that way. Um, it does require one con is that it requires special paper. It requires the special kind of film, which you have to order from APH. So um, you have to always have make sure that you have that on hand, and it's not something that you can just go out and buy at the store. Uh, there's also Tactipad um, and Sensational Blackboard, and both of those use normal paper. So you can use a normal paper and a pen. So you don't need specialized um, tools other than the devices themselves. And then there's tactile graph paper, which you can get from through APH, or it's just like your regular Braille paper with graph raised line graphs on it, so that you can create whatever graphs you need to create. And I think it comes in two different sizes with the larger squares and smaller squares. So depending on how complex your graphs and images are, you can choose which one you want. Um, some high-tech tools to interact with spatial concepts would be emboss graphics. So just, being able to um, use an embosser to create your tactile images. Um, and there's several embosser companies have their own programs for creating tactile graphics. There's also a device called the Tactonom Reader, which is from Germany, and it uses a camera. So it has like a board and a camera, um, and you can create graphics. And then while you're touching the graphics with your finger, the camera kind of detects what you're doing and can describe um, what you're checking out in real time. It's pretty cool. So it's great also for graphics and uh, images and all that kind of stuff for spatial math. Um, there are also multi-line braille displays. So the Monarch, which is from APH now, and DotPad X are two examples. So these are instead of having one single line of Braille in their refreshable displays. They have multiple lines, so they're capable of producing images that students can, in a refreshable format that students can check out. And Monarch has, in its software update, and I'm not sure if it's available separately, but it's part of a software update, the Wing It app, which allows you to connect like a iPhone or an iPad to the Monarch, and then you can create images on your like draw on the iPad, and those images will show up on the Monarch, which is pretty cool, and that's just instantaneous. Um, so those are some covering some of the um, tools that are available for spatial math and also for creating equations and yeah, that's that's that. And now Max is going to talk about the iPad.
Yeah, so I think that in the like interest of continuing like the tangent, I was going to talk about the iPad as a tool format and the feasibility of the product and kind of looking into the future like with a student. So I'm going to start with the question, can math be done on an iPad? And as I thought about this question initially, I don't really work in absolutes, so I couldn't say yes or no. I said that there are two answers to this question, or like two modalities that I think about when I think about iPads and math. The first one being that making math content on an iPad can be done if you're using LaTeX and or MathML, but it's not ideal for a few reasons. The first one being that you have app limitations. As far as I know, native to iOS, you can only do it on Pages, Numbers, and Keynote. But if you're having a student learn a math code to complete assignments when you're already crunch for time as a TVI with a caseload and IPs and other crucial areas of need for your students, it's not ideal. Like it's not to say that it's impossible, but it's not ideal. If you have the time in your day, definitely go for it because the language is going to carry that student as they go through higher level math anyway. Just be aware that it's just I just don't think it's ideal on an iPad. And then I also think about redundancy. So if the above is true, then the student would have been better off with a different primary device. So if they're using a Braille display for input, the same thing applies. So up until this current generation of Braille displays, I just don't have the that confidence in them to like have the fidelity of one-to-one input to output. I've seen a lot of them lag behind the user and start to miss characters. And then also mistyping one character as a brailleist really sets you back if you don't catch it in time. So I think that's my thought on it initially. And then visually, if you want to do math on an iPad, there are apps like Notability or really anything that does the same basic concept of taking a picture of math content and then enlarging it and editing it. They can work, but it depends on the student. Not every student is going to have enough vision or enough vision throughout the day without getting visually fatigued to work on a flow like that. It also doesn't require an Apple Pencil, but it's best uh, like the best use of that app usually comes with the Apple Pencil, and you're already talking like between 80 and $130, and that's pre-tax money for an Apple Pencil. There have also been some updates to the Notes app where when you handwrite, it'll interpret the data and turn it into like computer text, which is kind of cool. But I haven't tried it with using like superscripts or exponents or subscripts. But it's entirely possible. I just haven't played with it myself. And so I mentioned visual fatigue. There's also image clarity. You also have to teach a student file and folder management. And sharing, and these are all factors that contribute to a really oftentimes complicated workflow. That once it's set, it works for a lot of students, but it's not for all of them. So if you feel confident in your student learning and practicing these skills, it's doable as I said before, they translate to other platforms, specifically like file management and um, setting up your MathML or your LaTeX knowledge. I think that's really all I had to say about the iPad. I don't sound all that positive about it, but it's like there's no one size fits all for students, so it'll work for some students. It's just not my preference. And so in in the interest of continuing my in like pleading my case as to why the iPad is not sufficient, I'm going to tell you why a laptop is sufficient and the best thing for digital math. We're talking portability. We're talking versatility. As a primary device, I think it's fairly portable. It's not it's not smaller than an iPad, but ideally you have a reasonably sized one that's going to fit in a student's backpack, and it's more robust, in my humble opinion. It's more robust than the iPad in almost every conceivable way. You have less app limitations. Like I know a lot of the time students want to do some functions in docs and they're just not feasible. One of the ones I can think of off the top of my head is spell checking. Spell checking for whatever reason is really difficult. You become faster and you have better flows for creating materials on a laptop than you would on an iPad, and you can interface or interact with embossers as needed. Whereas on an iPad, you don't always have that option. And then the Braille response or the Braille display response is better when it's hardwired to a computer, in my experience. And Oh, and I also really don't like the cross app changes when I'm working on an iPad. So let's say I'm in Google Drive and looking for a file, and then I find it and I open it, and now I'm moving from Drive the app to Google Docs the app. And so I have two different things that I'm managing, where on a computer I don't have that same problem. Like it's all within this the same self-contained window. And most importantly, I think keyboard shortcuts. Keyboard shortcuts on a laptop make your life so much easier than an iPad ever will. Well, I to this point, to this day. And that is why we should move to laptops. Oh, in an ideal world, we should all move to laptops.
Cool. I think it's me now. So we got kind of a variation of this question multiple times, which was basically, okay, if I'm on a laptop, what's the best way for my screen reader student to access math? And since we just talked about laptops, we're going to talk about the screen reader. So the screen reader of choice on our recommendation is JAWS, and that is because JAWS has some wonderful tools in it that make math much more accessible. Sure, it um, doesn't take linear into spatial and spatial into linear, but it does allow for a depth of navigation that most screen readers don't allow for. So JAWS has something called, actually, let's start with, first of all, math always gets progressively harder. So from elementary to high school, it gets harder. It never gets easier, or else I would have liked math. So it always gets harder. So we need to think about long term for our students, especially our gen ed students who are going to have those higher level math classes and potentially even those higher level science classes that do involve chemical equations. And so we have the JAWS Math Viewer. Now, Max has been mentioning something called MathML and LaTeX. And essentially, MathML is the code that builds accessible math content on the web. JAWS, when it comes across math equations that have been written using MathML, then the JAWS Math Viewer can be activated, and a person using the screen reader can interact with the equation one number, one expression at a time. So if you had an equation like 2x plus 3y equals 5, you could have JAWS read 2x plus 3y equals 5, or you could navigate it by arrow. And so it might say, so the way it would go would be 2x then plus, then 3y, then equals, then 5. So you don't have to worry about memorizing that whole 2x plus 3y equals 5. And what if you wanted to verify that the and if you wanted to know or verify that it's a y or that it's an x, what you can do is then you would use your down arrow to go into that individual expression. So then you could navigate 2, then x, then plus, then 3, then y. So you have that variability of digging into an individual expression of an equation. So we're going to be emailing this resource document that we have, and I put a video, so the Cat Northwest does a really good job of demonstrating the Braille Math Viewer in their Tech in 20 playlist. Actually, I did that video, but then they have another one with the word equation editor that we'll talk about in a second. But essentially, you'll see what the math viewer does in those videos, and then you can also play around with it in another resource on the screen reader training website. It's a MathML builder that you can use to see what the content would look like if it were coded correctly and the correct interaction between JAWS and that math content. Now, so we talked about the JAWS Math Viewer, but we also need to talk about the JAWS Braille Math Editor. So yeah, we can view the equation. That's wonderful and fabulous, but now we need to write our work and turn in our math assignment. And a person with a Braille display can use Nemeth or UEB to now enter their answers into the math editor that is provided with JAWS. These are layered commands, and in the resource doc, we do have a step-by-step guide for how to enter math and how to view math. Now, we just talked about this accessible math content made with MathML and using the JAWS Math Viewer and using the JAWS Math Braille Editor, but we need to now talk about how that kind of computes in a laptop too. So our laptops have Microsoft Word, and again, Microsoft and JAWS have kind of partnered together so that JAWS works natively with Microsoft Word's equation editor. And this is accessible for both math consumption and math editing. And when I say editing, I refer to writing out your own equations too. So why the math equation editor? So, like I mentioned, MathML is the gold standard. It is, if you're familiar, it's WCAG code to accessible math on the internet. And the equation editor within Microsoft Word uses MathML as its backend to create math content. So when a math content is created in Microsoft Word's equation editor, it is called a math object. And so it is not an image, it is not a JPG, it is just a math object that now JAWS or can interact with in a similar way of navigating any kind of text. Also, so for the teacher side, it can accept like handwritten math or like screenshots. And then it can turn those in to math objects that would have that MathML as the back end and make them accessible to JAWS screen reader. Um, Now, let's talk about the elephant in the room, Google Docs. Most of my team members or anyone on CSV's campus knows how much I sing the praises of Google Docs, except for when it comes to math. So there are plugins like Equatio that can technically create accessible math. They sort of use MathML, but Google Docs natively does not work with MathML. So any kind of object that's created using MathML will be translated into a PNG, JPG, or IMG once inserted into a Google Doc. Then that math content no longer becomes accessible because it is attached to an image. So Equatio kind of has this little workaround where the math content, the MathML, becomes now an alt description, an image description. But that is not accessible because A, you can't navigate an image description in a granular fashion. You would have to memorize that entire equation at one time, or you might have to memorize multiple equations at one time, depending on how many equations have been inserted at one time using that extension, and to create that image. Second, an alt description only produces words. So if someone using a Braille display sees an alt description, they will see 6 plus 5 as SIXPLUSFIVE. So they will not have access to the UEB math or Nemeth math that they are used to. They will only read it as complete text. So it is not accessible at that point. So unfortunately, Google Docs fails the test really for accessible math content using MathML as the backend. It's Microsoft Word is far superior. And I did even test this. I was like, oh, well, if I download this Google Doc with this IMG that has MathML as the backend, maybe it'll download as an accessible Google or Word doc with the equation, but a picture does not magically turn into math content, unfortunately. So that workaround does not work. I thought it was going to be super tricky, and I was wrong. Now, some case uses that Equatio or Google Docs might be kind of helpful is maybe if a student is low vision and doesn't need all that much voice output or speech output. That could be one situation. Also, Equatio allows for entering a equation via voice. So you could technically say your answers or say your work out loud and then put it into that Google Doc and then turn it into your teacher, because the end product only needs to be read by the instructor and not necessarily by the student, although they wouldn't be able to review it very easily. But it may have its purpose. Like Max said, I don't want to say no to any tool. There's probably a case use for it in some situation. Now we're gonna talk about, we got this question, what should we be mindful when we're thinking about digital math content and accessibility? And I want to think about two things. So those alt descriptions, those descriptions for images, those are not accessible when it comes to math content because they don't allow you to explore on a granular level, like with the math viewer, because it is just text and it will only display as text on a Braille display. So MathML, another thing to be mindful of MathML is the only accessible coding language to create math content on the web, and it is the back end for Microsoft Word's equation editor. On the web, it's usually an extension called MathJax that creates the MathML translation so that content is accessible on the internet. So essentially, in a nutshell, if it's been created with MathML, it is accessible. One other thing I do want to touch on is we touched on alt descriptions, but let's say you have a really easy equation like 6x plus 5y equals 4. Technically, we could all write that out on our keyboard right now. We have all the correct keys on our QWERTY keyboard, but although you can still navigate it granularly because you can use it, you can read it as if it's just normal letters in a document. So you could use your right arrow to read 6, then X, then plus, then 5, then Y, then equals. The problem there is that is not going to be translated to UEB math or Nemeth math because, again, our screen readers are always reading the code that's making these programs and the internet. So it is not going to read a code that says that this is math content. So it will not translate that into the correct math for your student. Okay, and that leads us to Max talking about Braille note takers.
Sounds great. Although I have to be completely honest with you, I was just now wondering about Picture Smart with math content. And so I'm going to be testing after this, just to see if there's a way to get the AI portion to turn anything into math ML. But I digress. So my question was about Braille note takers. And so how do I put this? When I started working in this field, I fell in love with the Braille note taker. I thought it was the coolest thing, and it did all of these amazing things, and our students were so competent with them, and I tried to use them for everything. And I do still think that they are amazing. I still think that they're great, but I think that we have been due for some updates. And so, uh, essentially, Braille note takers with math content have always kind of had a few hiccups. Like the Braille note, you had to limit yourself to, I think it was 20 lines, and then you had to export the math and then redo the math mode to be successful with it. Otherwise, it would freeze. I've had some students complain about some issues with the Braille Sense 6, but by and large, students like these devices because they are comfortable with them and they enable them to complete their work at a comparable rate to some of their peers. So the content that is created with Braille note takers takes a couple different forms. So as an example, if you have access to BRF files and you send them to your students, the Braille note takers can interpret that and they can work through those. Similarly, if you create math content in something like Word using MathML, then it's super accessible on a note taker. And then I also really like the advent of KeyGraph, which you can use on the Braille note or the Monarch. You then also have access to making this material more accessible. Specifically on the Monarch, when you're graphing, you have much more real estate to work with. And on the Braille note, it is visually there for your teacher to see that you are completing the work as intended. So they both enable you to create math as a standalone user when you are in a text editor that is native to either the Braille note or the Braille Sense. So on the Braille note, you have your math mode and you can enter all of your equations and then do the print preview to check out your math and then export it and print it. On the Braille Sense 6, it's fairly similar. You have your math mode function, and then same thing, you type in all of your stuff, and then you export it. And that is all in Nemeth. And then, as I mentioned before, the problem that you may come across as a user or a teacher is that if you're not 100% confident in your code, you might have some extraneous random symbols that aren't math related, or they're not the symbol that you were looking for. Both of those devices allow you to find a specific symbol using the context menu. So you on the Braille note, you go to your file and then you go to your edit, if I remember right. Essentially, you can find any symbol that you don't know there, and then on the Braille Sense, it's similar. They have a symbols list, and you input it that way. Some students like to do that in the beginning until they learn the correct dot formations for the symbols. And that is what I have to tell you about Braille note takers. I still mostly stand by them, but I definitely think that we have some improvements to make in that area. And then as students transition to college and beyond, there was a question about the recommendations for students completing high school math. And as I said before, my recommendation is that students that are going to be really academically inclined and they're going to be working towards higher level math, I love the laptop or a computer, whatever works for you, with a Braille display and currently Microsoft Word. Mainly because of all of the workflow things that I mentioned earlier. It's just really smooth once it's up and running. And again, it translates from when you're building those foundational skills all the way up to heavy math. That being said, I also said earlier that there is no one size fits all thing. In our programs, for example, a lot of the students use the Braille Sense for math, along with, if needed, a portable monitor so that their teachers can see their work or guide them in fixing mistakes in their Nemeth should there happen to be any. We also have students that use iPads because it's most comfortable for them, even if it's not the most efficient thing. And these students typically work with Notability and an Apple Pencil, which thankfully we can provide for them. And again, even if it's not the most efficient thing, it's what works for them. And they really just they grow used to a very specific workflow and they like to stick to it. It's not ideal and it's not what we would push for, but the reality of life and specifically in our field is that there are some students that really just take to one thing and they stick with it even if it's not the best thing for them. Allison, you can take it away with the next question.
Our final question, probably the scariest question for most TVIs, is will my student have to learn MathML or LaTeX? Um, so with the caveat that I'm that AI is there and can spout out all the code you and I will ever need. If your student is going to try and pursue a STEM heavy career path in college or even in high school, taking maybe those chemistry, calculus, upper level math, and science classes where there are more equations and more chemical equations, um, I suggest that knowing the concepts of MathML and LaTeX, because not only would they be able to, so first of all, LaTeX is the shorthand for MathML. I like to call it like the text lingo of MathML. It's a lot shorter, and it doesn't require as much brain power, in my opinion, to learn. And a few LaTeX symbols or elements goes a long way for most of the math equations that you can find in standard upper level math. So I would say that having our students know what the concept of MathML and LaTeX are is really important because they can then understand why something is accessible and why something is not in their curriculum, and then advocate for the change, and understand what they're actually advocating for. Also, once college comes into play and those higher level math and STEM classes are on the horizon, knowing LaTeX might be incredibly important for your student to be able to keep up. It does show up in college classes, and professors may know it. I personally did not go into STEM, so I don't know, and I don't teach at a college, but I have definitely heard from STEM professors um, that LaTeX and MathML do become pretty important in the sense of knowing what they are and how to create math digitally as you do progress in the college courses that involve STEM and math. So knowing kind of those things. But for your standard student who's just trying to graduate, it may not be that important except for just knowing the concept of what it is and how it relates to accessibility. Now, that was our last question. Um, there is a resource document with all this good stuff in it that's going to be going out to those who registered. That is the awesome part about registering for these workshops is you get these resource documents. Um, it is going to probably go out in the next couple of days to those who registered. This will show up on our YouTube in the next couple of days. And our last Tech After Hours workshop of the school year is going to be in May on Braille note takers. And it'll be pretty exciting, especially given some of the new things coming in the Braille note taking world. So thank you for joining, and we'll see you next month.